if we were to put aside all the differentiation technique that we have learned at H2 Math level, looking at the solution to this VJC question, you will realize that the solution is actually a very similar set of solution as what you will see in O level, at least in terms of the steps and in terms of the logic. It is very, very similar to an O level rate of change question. But just like how you guys have experienced this week and like what I've shared with you for students who have been attempting this question in the past, this was seen as a very, very difficult rate of change question. Same set of solution, A level, O level, but this happened to become a very, very difficult question to do in the exam because of, do you remember? Because of what we have discussed in the last few weeks that makes an H2 Math question different from an O-level question. If you were to cast aside, the new concepts that we have learned at H2 Math level, one big difference when it comes to doing questions is that at H2 Math level, the instructional components from the question has been removed. For the same problem, for an O-level question, they will tell you step by step how to solve this. But at H2 Math level, they will remove some steps, they will remove some instructions, they will just show you the problem. And what we are supposed to do is to come out with the strategy to formulate the set of instruction that was actually removed. Okay, this is very different from how we have experienced when we were doing our topical revision. All the topical theories and topical experience that we had during our topical revision in the past few months, they are very, very crucial, definitely. But when it comes to exam, when it comes to solving problems during the exam, we need this extra skill, which is to be able to become mature thinkers, to be able to be someone who will be able to formulate your own strategies, who will be able to formulate your own set of instructions when the details, when the guidance, when the hand-holding part is missing. And I've gotten a lot of very positive feedback from you guys for the last few weeks as we were trying to focus on this particular kind of skill set. It is not something that is easy. We definitely need to put in a lot of hard work together. But I'm glad a lot of you are really trying. And now that we have highlighted this, you are seeing this way clearer when you are dealing with questions, when you are trying out papers. So I'm hearing a lot of feedback already. Please continue to do what you are doing. Okay, you guys are doing pretty well. So let's continue to persevere. It is not something that I can read and then I just follow the theories. Okay, there's not a lot of theories for this missing instruction thing. It is something that I want to try to embrace together with you guys because we can become more mature thinkers. It is something that machines will not be able to take away from us, right? So coming back to this, okay, the instructional component is missing. What is missing? What that is missing is how are you going to form the rate of change equation? In the O-level, if this were to be an O-level question, they will tell you one more place to position another variable, let's say x, so that you can form an equation between theta and x. Then subsequently, you can come up with your rate of change equation. So we need to find another place to introduce at least one more variable, x, so that I can bring in the geometry, the features of the geometry into formulating this equation that involves theta. So can you guys now think about it together with me? Okay, because it is missing in this question. Can you think about it together with me? Where do you think, if we have already decided, okay, that we need to plant in our own x? Because in O-level, they will give you, at H2 Math level, they are not giving you. So where do you think we are supposed to position this x? Any suggestion? Where do you think we are supposed to position this x? Okay, Ben has suggested one place to put x. Ben suggested, how about putting x here, AC? Okay, this is an isosceles triangle, which means that this can also be x. I guess this is possible. This is possible. I can definitely try to relate x to theta if I were to place x here. But this, I don't think it is the most convenient place to position your x. We can do something that is better. Can you think, Ben? Is there any place that I can position x that is even better than AC or BC? Okay, it is possible, okay, but is there any place, any position that I can any place that I can position x that is even better, even more strategic than this AC. Okay, Jerome suggested, how about angle A, angle BAC, angle A, right? Jerome, you're saying this angle, so I assume that you are referring to this as x. Well, this is also possible, but I think we still can be more strategic. Can you guys push a little bit more? Okay, because for when we are seeing question that is like this in an exam, what you realize is that there are some people who didn't realize that the instructional component is missing. So what they do is when they encounter this question, they'll immediately try to write down something. That means they will just write down the algebra. They'll just start some algebraic process without thinking. But this kind of question requires us to think, because there's no steps that tell us how to solve this problem. We are supposed to come up with those steps. We are supposed to come up with those set of instructions. So this kind of question requires us to pause and think in an exam. And since we are pausing and thinking, like what we are doing now, is there a strategic way that we can formulate this instruction? In an exam, we may not be the most strategic, that will be the most ideal case. But now, since we are able to discuss and we are trying to practice this, can you think of a more strategic position where x can be placed? Okay, Rachel, this is a good suggestion. Rachel suggested, how about this line here? Rachel described this as the shortest possible distance from C to AB. The shortest possible distance from C to AB. That means we are talking about 90 degrees here. Rachel suggested, how about letting this be x? This is the best position that I think we can place x. Why is this better than this and this? It's because of the information that is given to us by the question. If we were to position x here and then formulating an equation, we'll get an equation that is involving theta and x, which means that when we try to form our rate of change equation, we will have d theta dt, which is okay because the question is requiring us to find d theta dt anyway. We're also supposed to find dx dt. So the question didn't tell us what is dx dt, which means that we got to further do another set of calculation. The same goes for this x. The question didn't tell us what is the rate of change of AC with respect to t, which means that we got to calculate it later. But if you were to choose x here instead, since C is moving in the perpendicular direction away from AB at a speed of 2 cm per second, which means that as time increases, every second, x is going to increase by 2 cm since C is moving away from AB in a perpendicular direction. Which means that if I were to choose x here, I don't need to calculate because I spend a bit of time thinking. Instead of this and this, by choosing x as here, we immediately can get dx dt. That is why this is better than the other positions for x. So I'm going to, my instruction for myself in order for me to do this question is going to be this. I'm going to be letting x be here, which means that I'm going to be working on another triangle. This triangle instead of this entire triangle here. So for this particular triangle, this is x. This point here is C. This point here is A. Geometrically, this is going to be theta over 2. Because if you were to draw a line from the apex to the base in a perpendicular manner like this line is going to be cutting the angle at the apex as it's going to be a angle bisector, and it's also going to be bisecting the base. So this is also going to be equal to this, which means that this length, which is this length here, is of a length 5. And now we can create our own geometry. The geometry will be using tangent of this angle, theta over 2. It is going to be opposite over the adjacent. And if I were to differentiate this with respect to t, on the left hand side, we are going to be getting a half secant square theta over 2 d theta dt. On the right hand side is going to be minus 5 over x square dx dt. And the question requires us to find the rate of change of theta, the rate of change of angle ACB. So we are supposed to find this, which means that we're going to try to find this, and this, so that we can find d theta dt. And according to the question, what is the d theta dt that we're supposed to find? We're supposed to find when this triangle is equilateral. In the O level, they will just tell you the geometry, the numerical part of the more numerical version of equilateral. For example, they will tell you that these three lengths are the same, or if x were to be here, they will just tell you that x is equal to 10. But now they are saying that it is equilateral, so what is your interpretation? I don't think this is very difficult. Equilateral means that theta, this is the most convenient place where I can describe numerically what it means by an equilateral triangle. Theta must be 60 degrees, theta must be pi over 3, which means that when theta is equal to pi over 3, we are supposed to find d theta dt when theta is equal to pi over 3. So when theta is equal to pi over 3, we already know what is dx dt. This is great because we have paused and think how we are going to be generating our solution. So this is settled. This is definitely settled because we know theta is pi over 3, theta over 2 is going to be pi over 6. And how about x? Can we find x? We can make use of this equation, definitely. So one of the ways to find x will be when theta is equal to pi over 3, theta over 2, this is going to be equal to pi over 6. This is going to be 5 over x. I have a 1 over square root of 3, which means that x here is equal to 5 square root of 3. X is 5 square root of 3. And now we are ready to find d theta dt. d theta dt is going to be equal to half of secant square theta over 2, pi over 3 over 2, pi over 6. d theta dt, this is minus 5 over x square. So this square multiplying by dx dt, this is also found since x is found. So dx dt is equal to 2. So multiply by 2, and this will then help us to find what is d theta dt. d theta dt is minus 1 over 5. And like what I was trying to say to you guys just now, if you were to look at the solution and ignoring, differentiation techniques that we are learning at H2 math level, for example, implicit differentiation, the steps, the logic that is behind the steps are exactly the same as O level. And that is why if you were to be doing a question that is like this and you are stuck, and if you choose to instantly refer to your solution to try to find out why you are stuck. Okay, that means you didn't actually pause and think about how to do this question first. But the moment when you are stuck with minimal thinking, you look at the solution. Is the logic easy to understand? Of course it is easy to understand because it is the same logic as your secondary school. And it'll give you this false impression that, hey, I understand how to do a question that is like this. But do you really know how to do this question? Do you really know how to solve this problem? Because you didn't know how to solve it in the first place. So why does it matter that, just because you can understand the solution, then you will know how to solve the problem? That is why my encouragement to you is to continue to practice how we have been dealing with exam papers for the last few weeks. Don't look at the solution too soon. Okay, you can definitely look at the solution, but don't look at it too soon. What you should do is to try to give yourself the chance to think, especially if you are able to see a question that is like this and acknowledge that, hey, the key is because the instruction is missing. It may not just be the conceptual part. And if I were to look at the solution too soon, it may snuff out that chance that this question has provided me to actually practice on strategy, or to practice on me formulating my own set of instructions. Okay, and this is a very important skill at H2 Math.